Okay, let's look at another scenario of rationalizing the denominator. Sometimes the denominator is not just one single radical. It might be a sum or a difference. So when that's the case, we're going to rationalize the denominator using conjugates. The binomials a square root of b plus c square root of d and a square root of b minus c square root of d are called conjugates because they have the same expression with opposite operations. For example, this one has a plus and this one has a minus. So it's the exact same terms, a radical b, c radical d, except this one has a plus and this one has a minus, making these two expressions called conjugates. So we can use conjugates to help us cancel out the radical in the denominator. Let's look at how. We're going to use the conjugates to simplify the radical expression that contains a sum or a difference in the denominator. We're going to use the sum and difference special product. So if it is a plus, we're going to multiply it by a minus, and if it is a minus, we're going to multiply it by a plus. Remember, when you multiply a plus b times a minus b, the sum times the difference, remember the special product is a squared minus b squared. Now you could FOIL this out if you wanted to, but when you FOIL it out, remember the outers and the inners cancel out because this would be negative AB and this would be positive AB. So we don't need to put that there, we can just use the special product. Let's look at some examples. We're gonna look at example number 1. It says 7 divided by 2 minus the square root of 3. Now this, because it has an expression, a sum or a difference in the denominator, I need to use the conjugate. So this expression is a minus. The conjugate of this expression would be this with a plus. So I'm going to multiply, again, the numerator and the denominator by this expression, except with a plus sign. So I want 2 plus square root of 3 over 2 plus square root of 3. Again, this entire fraction really equals 1 because anything divided by itself is 1. So because I'm multiplying this by 1, I'm not changing the value, I'm just changing how it looks. And when I multiply this by the conjugate, I'm going to end up canceling out these radicals. So what we're going to do is we're basically going to multiply across the top and across the bottom. Across the top, I really want to multiply the 7 times both of these. It's like I'm distributing the 7 to this 2 and to this radical 3. So I want to distribute here. So let's multiply. Since 7 and 2 are both outside a radical, I can multiply them together, giving me 14 plus 7 times radical 3, remember there's really a 1 in front of this radical 3, that gets multiplied with the 7, so 7 radical 3. Now in the denominator, we're going to use this special product that we were talking about, this sum and difference. So this one is a difference, this one is a sum. I'm going to do the special product. If it helps you see it better, you can always put them into parentheses. This term is going to be our A. It doesn't matter which one you use. You can say this one is A or this one is A. And this one is going to be our B. And our special product is A squared minus B squared. So let's put that down here. We're going to have 2 squared minus the square root of 3 squared. Okay, nothing happens with the numerator. This stays the same. I cannot add them together because they're not like terms. This one has a radical 3 and this one doesn't. So they're going to have to stay separate. 14 plus 7 radical 3. In the denominator, let's square both of these. 2 squared is 4 minus the square root of 3 squared. The square and the square root are opposite operations of each other. So essentially, the square and the square root cancel each other out, and we're just left with 3. One more step, now we can subtract these numbers in the bottom. I would get 14 plus 7 square root of 3 over 1, but I really don't need to write the 1 in the bottom, so now I can just write my answer as 14 plus 7 square root of 3, and that is my final answer, just like that. Let's do some more. Number 2, we have 8 divided by 1 plus the square root of 3. Notice this time our denominator has a sum. The last time it was a difference. So when I multiply by the conjugate is going to be this expression with a minus. So let's multiply. We're going to multiply the numerator by 1 minus radical 3 over 1 minus radical 3. So again, I just took this expression, except I made it a minus, and I'm multiplying the numerator and the denominator. Okay, let's distribute on the top. We're going to multiply the 8 by both of these terms. So on the top, 8 times 1, I get 8 minus 8 times radical 3 becomes 8 radical 3. Let's multiply in the denominator. We're going to, again, use the special product. This is our A and this is our B. And remember, our special product is A squared minus B squared. Notice how I picked the A and the B from the sum. I did the same thing up here. I picked the A and the B from the sum, but it doesn't really matter which ones you use. So let's plug it in. It's going to be 1 squared minus the square root of 3 squared. Okay, let's simplify. The top cannot be simplified. These are not like terms. They don't both have a radical 3, so the numerator stays the same, 8 minus 8 radical 3. Let's simplify the denominator. 1 squared is 1 minus the square root of 3 squared. Again, the square root and the square cancel each other out. We're left with 3. We're going to subtract in the denominator. So we have 8 minus 8 square root of 3 over 1 minus 3 is negative 2. Now I can simplify this further, one more step. This 8, negative 8, and negative 2 are all outside of the radical. So that means I can reduce. I'm going to reduce these numbers and I'm going to reduce these numbers. Nothing is going to happen to the square root of 3. So let's divide. 8 divided by negative 2 becomes negative 4. Negative 8 divided by negative 2 becomes positive 4. Square root of 3 stays the same. And that becomes my final answer. Let's look at another one. I have radical 13 over radical 5 minus 2. Okay, we're going to do the same thing. We're going to simplify the denominator using the conjugate. Because this is its difference, I'm going to multiply it by the sum. So square root of 5 plus 2 over the square root of 5 plus 2. Okay, we're going to distribute on the top square root of 13 times square root of 5 and times 2. So because both of these are under a square root, let's multiply under with under. This becomes the square root of 65 plus, now this 13 is under, but this 2 is not. Technically, I'm multiplying the 2 with the 1 outside of the radical. So this becomes 2 radical 13. In the denominator, we're going to use the special product. So this is our difference and this is our sum. Let's call this A and this B. Our special product is A squared minus B squared. So this is radical 5 squared minus 2 squared. We're going to keep simplifying. Square root of 65 plus 2 square root of 13. Nothing happened in the top. I cannot simplify this. Let's look in the denominator. We're going to actually square these. The square and the square root cancel each other out, so I'm left with 5 minus 2 squared is 4. Let's subtract these numbers in the bottom. This just becomes 1. So I can just leave that denominator out. My answer is the square root of 65 plus 2 times the square root of 13. And this is my final answer. I cannot simplify this anymore. 65 does not have any perfect square factors, and neither does 13. And I cannot add these two together because they don't have the same radicand. They don't have the same number under the radical, so they are not like terms. That's my final answer. Let's look at one more. We have 12 over radical 2 plus radical 7. We're going to use the conjugate of this expression, which would be subtraction. So let's multiply by radical 2 minus radical 7 over radical 2 minus radical 7. Okay, we're going to distribute across the top 12 times both of these radicals. And the 12 is outside the radical. Both of these numbers are under, so the 12 is just going to get multiplied by the 1s in front of these. This is going to become 12 radical 2 minus 12 radical 7 over, let's use this special product in the denominator. Here's our sum, here's our difference. We can call this A and this B. Let's do a squared minus b squared. So we're going to have radical 2 squared minus radical 7 squared. Okay, the top cannot be simplified. We're going to keep the numerator exactly the same, 12 radical 2 minus 12 radical 7, over, let's square the denominator. The square and the square root cancel out for both of these, and I'm left with 2 minus 7. Finally, let's simplify this denominator. We're going to have 12 radical 2 minus 12 radical 7 over 2 minus 7 is negative 5. Now these 12s are not divisible by negative 5, so I cannot simplify this any further. This is my final answer.